Okay, Honors Algebra 1. Here's the most recent homework key. Just like last time, I'll go through it on this video, but if you just want to check your answers, I'll upload the PDF to Google Classrooms. So if you did it, you can just check if you did it right. If you didn't do it and you want to do it together, you can do it together. Whatever you want. Alright, so this is graph and quadratics. We already did a graph and quadratics from standard form. Most of these are in factored form. Okay. And we're going to, now you have the option, you could FOIL these and put in standard form, but it's good to know how to graph from all different forms. Okay. When we did linear equations, we were able to graph from standard form, from slope-intercept form, from point-slope form. It's the same thing with quadratics. You have three forms, and you want to be comfortable with all of them. So we're going to leave these in factored form. Alright, so we got factored form. In standard form, we have A, B's, and C's. In factored form, we have A's, P's, and Q's. Okay. So the A value is whatever's in front of the two binomial factors. In this case, there's nothing in front of it, so it's 1. Okay. Your P is 5, and your Q is -1. Alright, the direction of opening, is it up? Does it open up or does it open down? Same thing with standard form. It relies on the A value. Okay. This one's going to open up because you have a positive A value. Okay. Alright, the X-Intercepts. The X-Intercepts are unique to factored form. They're not easy to find in standard form, but they are much easier in factored form. So the X-Intercepts, remember, are always just P and Q. So in this case, we have an X-Intercept at 5 and -1. Okay. So it's always the opposite of those binomial factors. Now again, it all comes from the fact that we're using the zero product property. Because again, the X-intercepts occur when y is 0. Okay. And when y is 0, if you set y equals 0, then it just becomes a zero product property. If those two things multiplied together have to equal 0, that means one of them has to become 0. One of the x values has to make one of those binomials equal 0. So that's where that comes from. Alright, the axis of symmetry. Remember, the axis of symmetry is going to be halfway between your two X-intercepts. So we can do 5 plus -1 divided by 2. And you get an axis of symmetry of 2. Okay. Now, a pet peeve of mine is when people just write 2. The axis of symmetry is a line, so it's x equals 2. I guess we might as well graph this as we go. Axis of symmetry, we use dotted line, vertical dotted line. And we could put our intercepts on here, 5 and -1. Okay. Alright, so again, our axis of symmetry halfway between these two intercepts. Our vertex is going to be somewhere on this axis of symmetry. So let's find that next. To find the vertex, we're just going to plug in the x value of the vertex. We know the x value of the vertex is going to be 2, comma something. And we're just going to plug 2 back into the equation for x. Okay. So our equation was x minus 5 times x plus 1. And we're just going to plug in 2 for those x's. So 2 minus 5 times 2 plus 1. 2 minus 5 is -3 times +3, which is 9. So our vertex is at 2, 9, 2, 9. 2, -9. Oops. So we'll graph that down here. Alright, y-intercept. Y-intercept is A times P times Q. A value was 1, P value was 5, Q value was -1. So we got 1 times 5 times -1, which gives you a y-intercept of -5. Okay. Since we know that point is to the left of the axis of symmetry, we could automatically flip it over to the right side of the axis of symmetry. And we have 5 points already, so we're done. We could graph this. You can get another point if you want. That should be enough. Okay. There's still more questions here, so we'll keep answering. Min or max? Okay. It opens up, so it's automatically a min. And what's the min or max value? The min or max value is always the y value of the vertex. So it's -9. So there's no points below the vertex, no points lower than -9, which kind of leads us into the range. The range tells us what are the possible y values for this function. Okay. Well, if there's no values less than -9, that means all of our y values are going to be bigger than -9, or all of our y values are going to be greater than or equal to -9. And finally, domain, all real numbers. All right. So that's the first one. I'm going to go through the other ones a little more quickly. These other ones don't ask for as much information, but we'll find whatever we need. All right. The second one, you got an A value of 2, you got a P value of 3, you have a Q of -1. So your X-intercepts are automatically 3 and -1. Now your axis of symmetry, you can find the axis of symmetry algebraically. You add those two together, divide by 2. You can also just visually see on this graph, like we know it's going to be halfway between these two dots. Okay. So it has to be at x equals 1. Again, it doesn't ask for the axis of symmetry, but that's it, x equals 1. I'll write it down. The y-intercepts, again, multiply those three A, P, and Q values together. 2 times 3 is 6 times -1 is -6. Okay. Find the vertex. Okay, we know the vertex is going to be on the axis of symmetry, so it's going to be 1 comma something. If we want to find what that something is, we're going to plug in 1 for x. So we're going to do 2 times 1 minus 3 times 1 plus 1. That's 2 times -2 times +2, which is -8. Oops. -8. All right, and we could flip that. Flip the y-intercept. The y-intercept's 1 to the left of the axis of symmetry. That means on the same y value, we could go 1 to the right of the axis of symmetry. Five points, connect your dots. Whoops. Use the highlighter. That's not that bad. Okay. All right. This is the last one that's in factored form. You have an A value of -1/2. So that A value is negative, so it's going to open down. We have a P value of -2, and we have a Q value of +6. So again, right away, you can find the X-intercepts fairly quickly. It's just going to be P and Q. -2, +6. Put those on the graph. Oops. The y-intercept. y-intercept is multiplying a times p times q together. So negative 1/2 times negative 2 times positive 6. Negative 1/2 times negative 2 is positive 1. Positive 1 times 6 is 6. So you have a y-intercept at 6. Now to find the vertex, we have to find the axis of symmetry first. Again, you could use the axis of symmetry formula, or you could kind of just count it out. We know it's going to be halfway between negative 2 and positive 6. Okay. Halfway between negative 2 and positive 6, or negative 2 plus 6 is 4, divided by 2 is 2. So the axis of symmetry is going to be x equals 2, which means the vertex is going to be 2 comma something. Now to figure out that something, again, we're just going to plug in 2 for x. So negative 1/2 times 2 plus 2 times 2 minus 6. Alright, so negative 1/2 times 4 times negative 4. Let's see, that's negative 16 times negative 1/2 is positive 8. So our axis of symmetry is at, or not, our vertex is here at 2, 8. Now once again, you have a point that's to the left of the axis of symmetry in the y-intercept, but we didn't reflect it over, so we could do that now. That gives us our 5th point. Domain, all real numbers. The range, this one's a maximum. The vertex is the maximum, it's the highest point. So the y value of the vertex is going to be the absolute highest point on this graph, which again means that all points are going to be less than that y value, less than or equal to 8. All right, now this last one was in the most recent notes. It's where they give you the vertex and only an a value. So your vertex is out here at negative 6, 8. And we know nothing more about this graph other than the a value is negative 2. Now the a value being negative 2 always follows the same patterns. Okay, and that pattern is being from the vertex. If you go over 1 from the vertex, it's automatically going to go up 2, or in this case down 2, because a value is negative. And if you go over 2 from the vertex, okay, a typical quadratic with a being 1 would go up 4. But this one's going to go up 8 because of the 2. So it's going to go down to here. Okay. Now again, if we know the vertex, we automatically know that the axis of symmetry goes through that vertex. So you could flip those special points over, and it automatically gives you the 5 points. That's terrible. You get the picture. Alright, so that's the homework. Again, I'll put this PDF file on Google Classrooms along with whatever new notes we have for today.